So now that we've talked about the mechanisms and the structure and functionality and the methods and shown an example, let's talk about some usage considerations. In particular, how do we use this stuff effectively? So the first thing to remember, as we've talked about multiple times at this point, is you've got to make sure your reentrant locks are fully bracketed. So the thread that acquires a lock must be the one to release it. If that doesn't happen, then either you've forgotten to unlock a lock or you've unlocked somebody else's lock. Both of those are bad things. Ironically, forgetting to unlock the lock is actually a bigger problem because you probably won't get an error to discover that's the problem. You'll just get, your code will do something really strange, like hang. Conversely, unlocking someone else's lock is actually rather hard to do, but were you to do it, you'd get an illegal, monitor state exception or something like that. Always get in the habit of using the ScopeLocking pattern, which is a pattern that appeared in the POSA 2 book. You can read about it here, but basically it just says, acquire the lock before you do your critical section, and then always unlock the lock. And the easiest way to do that in this case is to use a try finally block, since Java doesn't support destructors. You can also use the built-in synchronized methods and synchronized statements, and they implicitly acquire and release the lock. They do the ScopeLocking pattern implicitly based on the syntax of the open curly brace and close curly brace. So the open curly brace and close curly brace define the critical section, and the open curly brace is where the lock is logically acquired, and the close curly brace is where the lock is logically released, and you don't have to think much about it. The downside, of course, is that you've got to live with the limitations of synchronized blocks or synchronized statements and methods. If we were in C++ or C#, we could implement this pattern using constructors and destructors. This is kind of the classic way you do it in C++. If you had some kind of a mutex, which is the C++ way of doing these things, you would have something called a lock guard, which locks the mutex in the constructor, and then when the object is destroyed, automatically releases it. And that's something called resource acquisition is initialization. Again, Java doesn't really support that idiom because they don't have destructors, so you have to use the try finally block instead. As we talked about before, ReentrantLock supports these recursive mutex semantics, where you can acquire the lock multiple times with the same thread without causing deadlock on yourself. And so, as you can see here, the way it works is that we are going to increment the count every time you lock it, and we're going to decrement the count every time you unlock it, and it's basically just a nice little state machine that keeps track of all those details. One of the things to remember about these low-level mechanisms is they can be tedious and error-prone to program. What I'm about to describe for you is very similar to the problems we looked at with semaphore from before, just slightly different because the semantics are ever so diverse. One problem is acquiring the lock and then holding it for a long period of time without really needing to. So you could acquire a lock, do something in a long-running loop that doesn't actually require the lock to be held, and then unlocking the lock down here. And that'll just kind of starve other people out from getting access to the resource. Another thing is to acquire a lock and forget to release it. So you could lock the lock and then return or have an exception thrown. This is why you want to use that try finally idiom, because that'll solve the problem for you. It'll always release it on the way out. So when you write your code, sometimes you won't do that, and I'll say make sure you put the try finally thing in. You're like, oh, but I don't really need to because I know what I'm doing. Just get in the habit of doing it this way. You'll thank yourself later because you'll just never have these bugs. You can also release a lock that was never acquired. That would be a big mistake. If you try to release something that was never actually locked, you should get an exception if you do that. Or you've already released it through some other means. That could happen particularly if you have complex conditional statements in your code. So that's, again, why try finally is useful to use, because you get around those problems typically. Another problem here is accessing a resource without acquiring the lock. So if you somehow have a path through your code where you don't acquire the lock, then you'll have a critical section that's broken because other threads could be running in there at the same time, reading and writing from the shared resource or the mutable shared data, and that will cause chaos and insanity, also known as race conditions. And you might think, how could this ever happen? Why would you ever do that? Well, again, if you have complex logic with if-else or loops in your code, you may forget to acquire the lock through some path. So The lesson there is keep your code pretty straightforward. Don't write 200 or 300 line functions or methods that have all kinds of crazy control flow and acquire locks some places and not others, unless you really, really, really know what you're doing. And even then, you should probably think twice about it. We'll look at some of the Java code in Java util concurrent and Java util concurrent locks later, and you'll see that there's some really, really subtle code in there that doesn't obey what I just said. And the reason that that's that way is because that code is infrastructure code. It pays to micro-optimize it. The people who wrote it are the world's experts on reasoning about synchronization. Don't try that at home, right? Keep things relatively simple and only do this kind of kamikaze crazy optimization if profiling reveals you have bottlenecks that can be solved through very advanced synchronization tricks. But otherwise, stay away from that kind of stuff. You will thank me later. Okay, that's the end of part 5 of Java ReentrantLock.